X is a random process and it's a zero mean Y sense stationary process. And also I tell you the autocorrelation function is Rx, and I have a Y is a function of X, and Y and theta is a uniform distribution, and theta is also independent of the process of X. First, find the autocorrelation of Y. Well, if you want to find the autocorrelation of Y, basic follow the definition is t plus tau times random process of yt. And since y equals x times cosine, so we substitute y equal to x cosine omega t plus tau. Oh, here's a little bit. It's omega t plus tau plus theta, and y is just xt cosine omega t plus theta. So now you can observe in this expectation, I have x is random process, t and tau is nothing, and w omega nothing, theta is also random variable. So since theta is independent of x, so we can put only x here, and the rest is for theta. 2 cosine here, I put in this way. So the first one, you know, that's the autocorrelation of x. And the second one, this, since theta is a uniform distribution from minus tau pi to pi, and then this we can combine those two. Well, it's cosine 2 omega t plus omega tau plus 2 theta plus omega cosine omega tau. Use your formula for 2 cosines multiplication together, multiply together. And since theta is uniform, so actually the expectation of this first term will be 0. 0 plus cosine omega tau divided by 2. And this term is no random variables here, so it's just cosine omega tau. So finally we have 1/2 autocorrelation of x cosine omega tau. Find the cross correlation. Cross correlation is expectation of x. First is t plus tau. The second one is only t. So this is also expectation of t plus tau. Y is xt cosine omega theta plus omega t plus theta. And since xt and theta are independent, so I can put the first, I can separate this expectation. And this is Rx, autocorrelation of x. However, this is 0, since cosine is even function and theta is uniformly distributed from minus pi to pi. So when you do the integration, you can still calculate, then you'll find it is 0. So here's 0. Part C is y, t is y sense stationary. To check if this random process is y sense stationary, first we check the mean. If we check the mean, we can find this is just mean x times expectation of cosine omega t plus theta. And since we know this expectation is 0, so this is 0. This is constant. Oh. Since the mean is constant, and the autocorrelation of y we found in part A is this, the autocorrelation function of x times cosine omega tau, which is only depends only on tau and no t. So the mean is constant, and the autocorrelation is not doesn't depends on t. It only depends on tau. So y, the random process of y is y sense.